Okay, so moving on, our next topic is nitrous oxide destruction and a greener NHS. And we have three speakers. We have Thomas Rutherford, Senior Specialist Engineering Manager at Royal Victoria Infirmary, Mark Lakey, Business Development and Key Account Manager at BeaconMedaes, and Jannik Jensen, Global Product Manager at Medclair. And I believe it's Jannik that's up first.
So thank you for the word. I must admit that I feel a little bit humble here being in present with those two lads sitting over there. As you can see, they have trophies on the table. So one trophy for Supplier Company of the Year and then another trophy for sustainability. And of course, I really enjoyed that trophy because that actually comes from a hospital. So the hospital here can give you guidance and address how this cracking technology can be implemented. But that's what we are going to talk about. We're going to talk about the cracking technology for Internox. Myself, yes, I am the global manager for Medclair. I have worked with the Internox as being a molecule for the last 15 years, working for a global gas company that you might know as BOC. I know them as Linde, but this is of course the biggest gas company in the world. And what I did for that company is I traveled out to different countries and educated about how to use this in a safe way, both for staff and for climate. So Medclair is a leading provider of sustainable Internox solutions. Our solution breaks down 99% of our captured Internox. We break it into nitrogen and oxygen, which is also known as air. So that is what we do. We have our technology both being mobile and central, so we can support all users, whether either this is dental use, maternity use, children use, emergency use. This is what we specialize in. We also specialize in measurement, collection, and destruction of N2O, and we are specialized in, of course, providing a safe work environment for staff, but also this thing about our climate. So why are we here? Internox programs, venting or collecting in the UK. A small story about myself. When I travel around to different countries, it's done in different ways, this Internox program. I think basically here in the UK, you stand all by yourself because nowhere else is it done like you do it here. If I now if I put myself in the US, if I put myself to Scandinavia, Australia, New Zealand, all of those countries, they collect the exhale gas because they focus on staff safety. Here in the UK, you do it a little bit different. You use a lot of open systems, meaning that you do not catch the exhale gas. You did a survey here in the UK, it was done by the obstetric anaesthetist in 2020. You had 412 replies on it, and 83% came back and said no scavenging. And scavenging means that you collect and remove the exhale gas. If I did the same thing in other countries, that would be an absolute no-go. They would throw me out immediately out of the hospital and say, hey, staff safety, where is that? So we do things a little bit different. That would be 100% yes to scavenging in Scandinavian countries. So of course, the conclusion is that most UK hospitals vent Internox to the staff, and you rely on good ventilation to keep staff safe. And to my knowledge, I have take a deep dive into the scientific articles over the last 15 years. I'm sorry to say that I cannot find any articles addressing that you can vent yourself out of the issue. And if you now think about it, you put yourself in a maternity department, that is by all means a very stressful environment using a lot of gas. I am pretty sure that you cannot keep under the threshold limits saying ventilation. So you use the same gas, you use the same type of department, we have the same level of education, but we have very different technical approaches to this. And if you look at the two pictures, well, picture number one illustrates how this is done in a typical Scandinavian department. So you can see that, yep, they use a face mask for it. It's licensed as an anesthetic gas. By that, you mean that you use a face mask. Here in the UK, it's a mouthpiece. And you can see that there's the exhalation hose going over to an outlet that will catch the exhale gas and remove it from staff. The other picture illustrates how most UK hospitals do it. So it's a demand valve. so far so good. We're doing pretty good on the inhalation system. Then the mouthpiece comes in, which really do not catch a lot of the exhale gas. And then you can see here that there are holes on the backside of this device, meaning that if that lady then exhale into that system, of course, everything that she exhales into that will come into the room, no doubt about it. So why do we need nitrous oxide and Internox programs? What I like about being here in the UK is that you have the NHS guidelines. I'm based in Denmark. We don't do everything evidence-based. Sorry to say. You have the NHS guidelines and they're focused on evidence-based practice. I like it a lot. So yep, here you have the interpartum care for healthy women and babies, and that states that Internox, of course, should be offered. Ensure the Internox 50-50 mixture of oxygen and nitrous oxide is available in all birth settings, may reduce pain, and all of that other stuff. So when I talk about Internox in different settings, I kind of present this as being one of the most cheap pharmaceuticals to use per patient. If you now think about what your hospital setting would look like, they come in massive cylinders, it's being piped into departments. Well, what are the costs per patient? I like the NHS guidelines because they also address this thing about cost versus effect versus, you know, a lot of other things. So the NHS guidelines are pretty clear on this, and yeah, you deal with a very, very cheap per patient pharmaceutical. Why do we use it? Well, when we address this with maternity staff and other clinical settings, well, it works in a very, very fast way, right? You apply a face mask or a mouthpiece, and then it starts to work immediately. So of course, that is why they use it. I mean, in most countries, they are now looking at you here in the UK and say, wow, you really use it in a lot of different departments, and that is good for you. I can give you an example of my own country. We don't use Internox on endoscopy procedures. We use propofol. It's a heavy sedative pharmaceutical that really requires a lot of competence within the staff group. I would rather give that patient a mouthpiece face mask in my country and say, you inhale this until you feel relaxed. It's a lot cheaper. So we use it because it has a rapid uptake and it, you know, really works in a very fast way. The same way about how do you get rid of it. This gas, Internox, does not metabolize in the body. So everything that you exhale will be pretty much the same as you inhale. Also why this thing about the venting thing, that can you vent yourself out of the issue? No, the 50% that lady will inhale into a maternity department will pretty much also be the 50% that she exhale back into the room. So in my mind, you cannot absolutely not vent yourself out of the problem. Why is it a problem with this Internox? Well, 1 kilo of N2O is equal to 298 of CO2. It really catches heat. So when you use it, well, you basically 1 kilo of this is equal to 300 kilos of CO2. It will be in the atmosphere 114 years. So it will pretty much, you know, outlive the most of us in this room. So the lady inhaling this gas, well, it will outlive her and her baby. Also why we need to address this about the climate effect. Exposure to nitrous oxide should be less than 100 ppm during 8 hours work. You have the TWA, this is the time-weighted average. You have the COSH regulations looking out for this. So there are limits to what you can expose staff to. Both intelligence, of course, can be solved, and this has been done in Sweden since 2002. I represent a very old technology. The cracking technology was invented in Sweden in 2002. And if you now travel to Sweden, and please do, all hospitals will use this technology. It was implemented back in 2002. This is what we talk about. We talk about, you know, the anesthetic gases as being an issue. This is the net zero document that I've just copy pasted from. We're in scope 1. So scope 1 also addressed anesthetic gases. We're looking at emissions from our own buildings. This is, of course, anesthetic gases. If you now go into that group of anesthetic gases and say, yeah, what about that Internox program that this guy is talking about? Well, it comes out with basically 5%. This is including anesthetic gases, but 5%. And if we then focus on, okay, where do we get most benefit out of now going back to our trust and do something about it? Of course, maternity departments. Maternity departments are by all means the heavy users. Think about the procedure length. This is not 5-minute procedures, giving birth to a baby. So yeah, go home and focus on maternity by all means. So what do we do with our technology? Well, by heating nitrous oxide, we know that we can split the N2O molecule. So we can split that to being oxygen and nitrogen, room air, and we can do that by heat. So at 500 degrees, we can split that to being oxygen and nitrogen, room air. So yeah, the technology was adopted in 2002 in Sweden. What this does not say is that that was, of course, a political-driven demand. Political-driven demand in 2002. The politicians started to raise questions. 83% of delivery rooms do not have scavenging. How do we split, destroy, replace, venting, move to collection like done in Scandinavia? Why collect the Excel gas? Well, of course, you need to address the staff safety, absolutely. Health staff who work in maternity service are frequently exposed to N2O. I have no doubt about it, they are. And the consequence is, of course, that you can have myeloblastic anemia and pregnancy complications. It is a pharmaceutical and you should address it like that. With occupational risk, the simple concept of dose equal concentrations multiplied by duration of exposure is affected by restitutions. And what I mean with this is, of course, that hey, maternity staff are heavily exposed and they work with this over and over and over again. Their body does not have the time to recover. We don't know how, when does that stop? When can you not recover anymore? But by all means, we know that this is not good for them. Thank you.
Thank you, Jannik. Afternoon, everybody. Thank you very much for coming. My name is Lakey. I'm the UK Business Development and Key Accounts Manager for BeaconMedaes. I've been in the medical gas industry for over 20 years now. First came engineering background, and I first came into the industry as a medical service engineer and then progressed through into the sales side of things. So this kind of technology was fascinating to be involved with, and obviously from a sustainability perspective, it's a really good area to be involved with. To give you a bit of a background for the CDU as well, it's important to get a bit of a grasp on your nitrous oxide and your Entonox, the history of it. It's not just something relatively new. Over 200 years, it's been in existence from different areas of anaesthesia and pain relief. You can see from here, it's also known as laughing gas, which is an interesting term for it, but coming from self-medication, it's been used as an anaesthesia for dentistry and maternity, which is what we tend to refer to from an Entonox perspective anyway. And obviously from the 1970s it also came into as a pain relief from the UK ambulance teams and paramedics. To give you a bit of an idea, to understand the how, one of the big areas that's really critical for the CDU is the CDU is only as effective as the amount of gas it can actually capture. So one of the starting points we have from a system is your acoustic audit. We need to eliminate leaks on the system, so as much as possible the bottled gas that we have from either your Entonox or your nitrous oxide manifolds, it's imperative that we try and rectify any leaks. We do this initially through we have an acoustic camera which actually measures the flow of leaks, so you can get an idea of your litres per minute that you're using. And it's obviously it's a new technology that replaces your wet test when you used to do the bubble test on the systems. So one of the first things we do is we do an acoustic audit, rectify any leaks on the system. So the idea is that from as much of the gas, 100% of the gas that leaves the manifold is reaching the clinical interface. The next stage, to give you a bit of an idea, is on average about 20 bar in an EW cylinder is returned to the supplier, which unfortunately, to give you another idea, it's about 8.6% of the volume of the gas then goes back to the supplier and is then vented to atmosphere, which again, as a tree hugger, it's not really ideal for the atmosphere and for the ozone layer. The next stage as well is the clinical interface. So what we need to try and do is minimise the amount of nitrous oxide or NTNOx that is escaping into the clinical area. So we're trying to protect, as well as from the carbon footprint perspective, the exposure to the midwifery teams around the clinical area. This is involved with the idea, typical is a mouthpiece that you'll see in the birthing process, and the ideal is to take that to the mask, which is a challenge within the UK, to be honest, because you get the typical, we've always done it that way with the mouthpiece, but when we look at the guys in Scandinavia, they've gone to the extreme with the full face mask, so that's the journey that we need to do. So what we have is, within the clinical area, we need the AGSS system. It's like Jannik said, there's probably 83% of our midwifery delivery areas don't actually have AGSS, so it's another challenge that we have from an infrastructure point of view, where we are installing the CDU. To give you a bit of a background, the CDU works on a catalytic process whereby we heat the captured gas. So what we get is above 450 degrees. You get the natural chemical reaction where the nitrogen separates from the oxygen. Within the CDU, we have a palladium reactor. The palladium then absorbs the nitrogen, which has been cracked and separated from the oxygen, and then we then have a 99% oxygen, which is then passed out to the atmosphere. The Newcastle RVI, working along with Tom, and Ian was the first one in the UK for ourselves with the CDU. So it was a really interesting process. Obviously, from my perspective, being from the northeast, it was nice that it was on my doorstep. But from a process itself, it is a fascinating process. To give you an idea then for a project flow, this is what we used on the RVI, and it's exactly the same project flow that we would use for every hospital that we come into. So we have initial survey where we establish whether the hospital actually has HSS in place. We discuss with the user teams their kind of clinical process during the midwifery process during the birth. We then analyse what we need to do from a system design perspective. So we're BIM compliant, we size the system, analysing flows, the citation of the CDU in relative distance from the delivery suite. We then come in with the product supply, the pipeline installation, which is taken care of by ourselves. That was one of the attractions for ourselves, as well as Medclair when we partnered up, is we cover all areas from the initial design. We manufacture the products. The product in this case is manufactured by Medclair. Our nationwide installation teams then install it, and we're also set up for a nationwide maintenance. So from a commissioning and training and maintenance perspective, we can cover all angles. One of the areas that is imperative with the CDU is that we're handling pure nitrous oxide and NTNOx, not your halogenated drugs that you have in theatres. So what we're looking at is your pure gases with no contaminants, because it has a detrimental effect on the palladium. So the system here, give you a rough idea from a schematic. You have the outlet within the clinical area in the delivery room, which is connected to the face mask or the mouthpiece through a demand valve. The system then, with the AGSS, draws the exhaled NTNOx from the mum during childbirth. It then comes through the AGSS system, which typically before the CDU is in place, the exhaust from the AGSS just went out to our atmosphere, which is obviously the big area where we're affecting the carbon footprint. So the system now with the CDU, the exhaust is then rerouted through the CDU, so it's a relatively easy add-on. I mean, the technology's complex within the CDU itself, but from an infrastructure upgrade, you're just rerouting the exhaust through the CDU, and then the exhaust then continues on from the CDU to atmosphere, which at that stage is 99% pure oxygen, which is where the carbon footprint reduction takes place. Just to give you a bit of an idea, this is an example from our BIM and CAD team. So when we're designing the system and the location, we can come up with from the estates and the engineering guys, and we can give a good perspective on location and design for plant rooms. The CDU has a cloud-based data, so your estates guys and your sustainability guys can monitor the performance of the CDU from a distance. This is data that was kindly shared from the RVI over a 12-month period, so it gives you an idea of the kilowatt usage. The system itself is 4.5 kilowatts from an energy consumption for the CDU. So this is for the 12-month period. We'd actually collected 240 kilograms of nitrous oxide. And like Jannik said, it's 298 times more potent than CO2. So with the calculation over the 12-month period, we'd actually cracked 71.5 metric tons of CO2. Over a 10-year period, it gives you an idea. You're talking about 715 metric tons. And just to give you an idea as well, when we compare, if we're adding in about 20 trusts, 100 trusts, you've got a measure of how effective and the reduction of the carbon footprint across the NHS is capable of. Just one of the last slides here. This is an interesting paper that's out there that's it's well worth reading, because we found the difference in the clinical area going from the mouthpiece during childbirth to the face mask. It's a 10% increase, so it's a work in progress from our perspective for converting the clinical teams from the mouthpiece to the mask, but we increased the capture rate to about 81%. There's a little bit there that does escape, but on the whole, we are capturing about 81% of the system. That's a paper that was issued by the Association of Nitrous, and that's it from my side. Passing it on.
Yeah, hi everybody. My name's Tom Rutherford. Work within the mechanical engineering team at the RVI. So whilst Jannik set the scene on the product and Mark spoke about project delivery, I thought it was important to talk about the specific project delivery at the RVI. We have 12 months worth of data now, so we can kind of share the results and how we got it implemented. So we set up a project team initially last year, and that was with a simple goal. It was to continue to offer Entonox to labour and women. There was some trusts at the time were looking to withdraw it through fear of staff risk. So it was to maintain Entonox usage, but also adopt new technology to the UK and significantly reduce greenhouse gas emissions and improve the health of the midwives. So that was the project goal. To give you an example of the size of the trust, just to compare with your own, the trust is Newcastle upon Tyne hospitals. We have two main sites, RVI and the Freeman, approximately 1,400 bed capacity and 17,000 staff, an annual income of around £1 billion. So the maternity department that we are referring to and where the project was delivered consists of 2 operating theatres specific for maternity and 13 birthing rooms. The annual births is about 6,000 per year, and our BOC data for cylinders suggests we use 5 million litres per year of Entonox at the RVI. So now we had established the project goal, we set about how we were going to deliver that. So we created a multidisciplinary team, and as you can see up there, that's the project wheel and the key stakeholders to get that delivered. So we had engineering representation, which was mainly medical gas APs, anaesthetics, which was quite important, the midwifery team, ultimately for the project to work, we have to engage those individuals and the sustainability team, because we actually started our relationship with Medclair through the sustainability approach. That focus changed once we established what the background effects were in the rooms, so it quickly shifted from the sustainability goal to the workplace exposure goal. So that's a project wheel and the key stakeholders, and then there's some of the companies and key support people that helped get that over the line. So what challenges did we face? So the first issue was that the HTM didn't acknowledge the CDU technology. So these are our national guidance documents, and because it was new to the UK, we had to consider it, use it, but then be cautious that there was no guidance about it for its use. So that was a challenge. Access for maintenance and installation. Anyone who works in a hospital and operates or has a maternity department on site will realise that you cannot access that space. It's one of the busiest departments in the hospital. We had the clinical use, so we were just using demand valves with no exhalation device. So we had to come up with a solution to capture that gas, and we worked with BPR to do that. There was of course a capital investment. We needed to find the money to install it. The reputational to consider. There was a lot of press coverage about the withdrawal of Entinox in the country. So we wanted to make sure that whilst we were going to continue to use Entinox, it was going to be done in a safe manner. So that was a consideration. Staff training, of course, and mindful of the COSH exposure limit. So that's a statutory regulation that we possibly were going to identify a breach of. So there was that, and then we had the issue around using a standard a scavenging outlet when it wasn't for a HTM compliant scavenging system. And then our next task was to establish Entinox usage. So once we'd established those areas, we delivered the project, and this is the results. So the CDU with 12 months usage has saved over 75 tonnes of CO2 in the last 12 months. We have a combination of CDU and MDUs on site now, and we project with human factors and other capabilities we can exceed 1,000 tonnes of CO2. The health benefit, which was the big advantage for me, is the exposure levels have reduced by 80%. So we were measuring an average of 178 parts per million in the midwifery-led unit delivery rooms. That's reduced to 33 on average. So the scavenging is doing its work, it is capturing that exhaled gas, and ultimately the staff have a safe environment to work in, whereas they didn't before. And then scalability, Mark touched on the scalability side of this in his last slide. If we were to implement it throughout other trusts, 132 high impact trusts, we'd be looking at 90 tonnes of CO2 saved. So quick slide, this is the RVI performance versus the hospital in Copenhagen, similar size maternity unit. What you can see from the data is that Copenhagen system is 3 times more effective than the UK system, and we believe that to be the clinical factors, the factors that we spoke about, using a mouthpiece over a mask. That's a big driver, and of course it's a culture change that we need to implement in the UK around staff exposure. Positive findings from that data is the RVI is the bottom line, and you can see a positive linear trend in usage and capture there. So hopefully in the next 12 months we'll start to perform like Copenhagen system is. And last slide from me is future aspirations. So it's a new technology. We can see the issues with capture. So we would like to consider the use of face masks. Again, that's going to be clinical led. Engineers can implement face masks in maternity wards. I wouldn't try. Engagement, so more training for the midwives. We want to look to put physical metering into the Entinox system. So the 5 million litres I quoted before is on cylinder data. We don't know exactly how much is just going to the maternity department, because it goes to A&E, goes to Burns unit, and various other places. So to work out how effective the CDU is, we need to know exactly how much gas the maternity department's using. We have life cycle to consider. 10 years life is the quoted life of the palladium reactor. So we need to be looking to the future and seeing how we're going to change that. And there's an option for a process facility. So we know 10% of cylinder goes back to BOC and is vented to atmosphere. So if we use this technology to vent that cylinder on site, we wouldn't be liable for that capture. We would like to develop an exhaust outlet, add 2 more additional rooms which aren't on the system because they've had new trunking installed. We would like to see some HTM guidance on this technology, and possibly variable speed drive on the vacuum pump. So thank you for listening. I'll take down rather than take any questions directly, and yeah, we're looking forward. Thank you.
Thank you, Tom, Mark and Jannik for that. Well, you've heard some fantastic presentations, I'm sure you'll all agree. Now it comes to the questions and answers sessions. So if you do have a question, if you could put your hand up, please. We have a roving microphone, so if you can wait for the microphone to arrive, state your name and then ask the question to the panel. So does anybody have any questions, please?
Hi, I'm Raj. I work for Birmingham Women's and Children's Hospital, senior APD defence. And last thing, I'm really interested in your UVC technology and want to know how far you are from real world trials, and if any work was done with Durham to see how it can be implemented in the real world.
Thank you.
If you just put it closer to your mouth.
Yeah. What? Yeah. Okay. But just you mentioned a part of UPC with Bobo.
Yeah.
We didn't put that in our chain by our but why we think we needed to use the 5 UVC inside the room, you mean without Dubai? So that's why we need to use what?
The technology relies on exposure rates.
Okay.
And with doors opening and with people coming and going, windows opening, the exposure rate is going to be slightly reduced.
Yes.
So your trial was done in an enclosed room that built at the university, whereas if we put that into a real world environment, would you get the same results?
Yeah, that is a good question. Yeah, it could be, which is that I'm not aware of something happened, maybe or something study happening in real world, and with the 5 UVC.
Yeah, so there are 1 or 2 real world trials starting. I think I've seen one where somebody's looking to put it in care homes in the US, and because one of the things with 5 UVC is you can sort of flood a room with it, so it's safer. We've also seen some data which is not quite real world, but is from an animal husbandry unit in the US, where there's quite high concentrations of murine virus from the animals. And again, you see this really quite spectacular reduction in, you see really, really spectacular reductions in the concentrations of the virus in the air. But in terms of actual implementation, there's a few test implementations more from a sort of safety acceptability perspective, but the actual, it's not got, I mean, you can buy it commercially, but it's not got to the point where there's trials in hospitals.
But still, the research about the level of ozone, I think, on real environment is still not fully in this.
Hi, Darren here. Yeah, actually, that's part of was my question is how much research is going into the sort of biochemistry change that could happen with bio-UVC, certainly with different chemicals and various other bits. And then secondly, what's the long-term goal of bio-UVC? Well, what from a microbiological standpoint, do we have a risk of bacteria starting to become resistant to bio-UVC in the near, well, maybe not in the near future, but eventually? Is this just a stopgap for eventual change again, if that makes sense?
As I know so far, I don't think there is a research with resistance and that, with a lot of stuff like that. For the first question, there is need like more research about that technology, to be honest. Interactions between particles, chemicals, especially we need to do in controlled environment first, then after that in real world. So still there's a lot of questions we don't know yet.
Do we have any more questions? Anybody else? Yes, we have one. Here we go.
Yeah, and just about the CDU, do you offset, you said 4.5 kilowatts to run the unit, would you offset that CO2 against the actual CO2 carbon footprint saving that you make when you use this machine?
What I kind of like about this technology is that it's old, meaning that the life cycle cost versus the effect has been made. They're very thorough on this in Sweden, where they do analyze on both the life cycle cost and the life cycle assessment. So they take both things into consideration when they establish new technologies. And just to give you an example where we're not quite clear on it, I drive a hybrid car myself. I'm not sure I'm doing something good for the climate. I don't know what will happen with the battery, but you are right. The kilowatt that you need to use on this technology, it will be there, right? But think about the kilos that you're saving the planet for. I mean, it's not 1 kilo of N2O that you're collecting and destroying. It's 300 kilos of CO2. So that into consideration will really have an impact on life cycle assessment, where you consider everything.
Is the machine on all the time?
Machine is on all the time, but it depends on the flow that it gets.
To how much power it consumes?
Yeah. Thank you.
Okay. Any more questions of anyone? Okay. Yeah, we have one.
Sorry, my name's Ben Slavinsky. When we comparing Copenhagen to the UK, and with them using more masks in the kind of clinical areas, does that have a greater impact on the amount of flow that's actually going across the unit, and does that impact the efficiency and performance in any way of the unit based on masks versus what we use in the UK at the moment?
I think Tom did mention it, that one of his wishes was regarding the AGS system, that the AGS system will have an impact on our unit. So let's say that you have this unit that heats up to the 500 degrees because that's where we want to split the nitrous oxide. Well, that will have an impact if you now have an AGS system constantly running, trying to cool down the unit. You know what I mean by that? So yeah, I mean, the Copenhagen Hospital, they use an AGS system that kind of only operates when midwives plug into an AGS outlet. Then that starts to operate and generate the vacuum. So this is important, of course, and that is also what Tom did mention, that this is also what we're working on at the IVI. Absolutely, yeah.
Okay. Any more questions? Yes, we have another one here.
When you're not using a mask, how do you get the AGSS pipeline close to the applicator device? How does it practically work?
So
Sorry, what was that? When you're not using the mask?
Yeah, so we don't use a mask. We have AGSS line coming in,
Yeah.
and we've got the device which you inhale the gas through. How do you capture the exhaust gas?
So the demand valve has to remain in the mouth. So you have a pipe coming from your terminal unit for your Entonox to the demand valve. It's inhaled, and on the mouthpiece there's an exhalation tube which goes through an air brake to an AGSS outlet. So the clinical practices or the clinical changes leave the mouthpiece in your mouth when you're exhaling. Because if you take a breath of Entonox and you remove that, you won't capture anything. So that's why the mask is preferred, because there's too many human factors in it. Say if somebody's used it before, they may just use it in the normal way. So it's kind of subjective to the user. There's a lot of onus on the user to understand to leave the mouthpiece in.
Did that take quite a lot of education?
I didn't honestly get, so all I see is the data, and you can see the linear trend in that clinical practice. So it looked like it has been quite difficult, yes, because we went from tracking next to nothing in the first month up to peak levels that we're at now on that linear trend. So yeah, I think the clinical staff, midwifery in general, is struggling with turnover and retention of midwives. So of course that brings with it its own issues with training.
Okay. Apologies for the problems with the microphones. Anybody else have any further questions? If there are no more questions, I will bring the session to a close. Could we put our hands together, please, for our four fantastic speakers?